Hi everybody, this is the beginning of chapter 5. This video will cover sections 1, 2, and 3 because they're not very long sections, so I grouped them together. And you will notice when you go to do your homework, chapter 5, the homework assignment is all in one big chapter because again, the first 3 chapters aren't very long, and the other 3 are not bad either. All right, we're going to start with section 5.1, and we're going to look at perpendicular and angle bisectors and triangles. All right, so if you remember previously in another chapter, we talked about a perpendicular bisector. Remember, if something's perpendicular, it meets the other line at a 90-degree angle, and a bisector cuts that line segment into 2 equal parts. So we're going to talk about perpendicular bisectors, and we're going to use this for our perpendicular bisector theorem. And this theorem says if a point is on the perpendicular bisector of the segment, so if we look here at point P, it is on the perpendicular bisector, then this point is equidistant from the endpoints of the segments. So what they're saying is P is always going to be the same distance from the endpoints of the segments. And it doesn't matter where the point is on the line that is the perpendicular bisector. That point, the lengths may change from the distance from the point to the end of the segment, but it will always be equidistant from both endpoints of the segment. And so here we have the converse of that, and that just says if a point is equidistant from the endpoints of a segment, then that point is on the perpendicular bisector of the segment. So now we know the point here is equidistant from the 2 segments. So that means that it is on the perpendicular bisector for that segment. All right, so here we're going to use our perpendicular bisector theorem to find the length of AB. And we know through our given information that segment BD is the perpendicular bisector of segment AC. So that means that B is equidistant from A and from C. So that means that this segment is equal to this segment. So to find the length of AB, because the 2 segments are equal, we can just take our 2 lengths and set them equal to each other. And then we'll solve our equation. So we can subtract 6x. Now I have negative 2x is equal to negative 10 divided by negative 2. So x is going to be equal to 5. And then that means we'll plug that value in for x. So AB is 4x, so we'll do 4 times 5, and we end up with 20 units. So AB, the length of AB is 20 units. Next, we have the angle bisector theorem. And this theorem says if a point is on the bisector of an angle, then the point is equidistant from the sides of the angle. So we have ray QS here that bisects this angle, angle PQR, and it is perpendicular to ray QP. So SP is perpendicular to ray QP, and SR is perpendicular to ray QR. So that means that SP and SR are the same length. And here we just have the converse of that statement. So now if we have a point that we know is equidistant from the sides of the angle, and it also has to be perpendicular, but the perpendicular segments are equidistant, then that point is on the angle bisector. So if we were to draw an angle bisector, it would be on there. All right, so here we are going to use the angle bisector theorem. And we are given the information that NR, ray NR, bisects angle LNQ. I know that RM is perpendicular to segment RM is perpendicular to ray NL. Segment RP is perpendicular to ray NQ. So that means that MR and RP are the same length because they are perpendicular and they come from the angle bisector. So we're going to solve it, we'll just do 7x equals 25, or 2x, excuse me, plus 25. We'll subtract their 2x to solve it. So we get 5x equals 25, divide by 5, and x is going to be 5. So they want the length of RM, so if we know that x is 5, we'll do 7 times 5, and we end up with 35 units. All right, that brings us to 5.2 and 5.3. And what we're going to look at in 5.2 and 5.3 is we'll look at the bisectors of a triangle and then the medians and the altitudes of a triangle. We're not going to delve too deeply into this topic. We're going to identify them and look at them, but we're not going to, there's a lot of properties that go with them that we aren't going to get to in our course. Okay, so our first thing that we're going to look at is going to be a perpendicular bisector of a triangle. And a perpendicular bisector of a triangle is a line, or it could be a segment or a ray or a plane, that is perpendicular to the side of a triangle at the side's midpoint. So what I want you to notice about this perpendicular bisector is it does not come from a vertex. It is simply a line, or again, a segment or a ray or something that is perpendicular to one side of the triangle, and it's a perpendicular bisector, so it cuts it into two equal parts. Now, I'm going to ask you, how many perpendicular bisectors does a triangle have? Hopefully you answered 3, because there are 3 sides. So there is another perpendicular bisector, and again, my line won't draw straight here, but that is perpendicular to a side and cuts it into 3 equal parts, or excuse me, 2 equal parts. And then on the third side, again, there's a line that will be perpendicular to the side and cut it into 2 equal parts. So again, there's 3 perpendicular bisectors for a triangle. Next, we're going to look at a median of a triangle. And a median of a triangle, the key thing here is the median does come from the vertex of an angle and goes to the opposite side, and the median will always connect to the midpoint of that segment, so it will cut the opposite side into 2 equal parts. It doesn't have to be perpendicular, it's just a line. And again, every triangle will have, 3 medians. So again, from this vertex, we'll have a segment that will go across and cut this side into 2 equal parts. And then from the third side, you'll have another segment or line or ray that will cut that side into 2 equal parts. So the key thing to identifying a median is it's going to come from one of the opposite angles, and it's going to divide the opposite side into equal parts. Next, we have our last thing that we're going to look at in this section. It's an altitude of a triangle. And an altitude is going to be a perpendicular segment, but it's not a perpendicular bisector necessarily. It's a perpendicular segment from a vertex of the triangle. So that means it's going to come from the opposite angle, the opposite vertex, and go to the opposite side. Now, an altitude, whereas a perpendicular bisector was always inside that triangle, at least when it cut the line, an altitude could fall inside or outside of the triangle, or it could be used as a side of the triangle. So if you take a look at the picture here, we've got 3 examples. The first one, the altitude goes from the vertex of A to the opposite side and it's inside the triangle. On the second one, the altitude is outside the triangle. And then the third one, it is actually the side of the triangle. And it will be the side of the triangle when you have that right angle there. Okay, and the last thing they want us to do is we have triangle PQS, and they want us to identify if QT is a median, an altitude, or neither. So if I look at QT, it is right here. It goes from a vertex to the opposite side, and it divides that opposite side into two equal parts. So what will that make it? What will it be? Hopefully you said median, because the median comes from the opposite side and divides that side into two equal parts. All right, next for PR. PR goes from the vertex of angle P to the opposite side of the angle, but it's on the outside and it's perpendicular to segment SQ. So that is going to make that an altitude. And that is it for sections 1, 2, and 3 for chapter 5.